solve some theory of inference problems. Our problem is show that R then S can be derived from the premises P then Q then S. Second one is negation R P. Third one is Q. Solution. Here our answer is R then S, but in given premises there is no R. So I introduce R as an assumed premises. So step number 1, I introduce first premises as R. R is an assumed premises. Assumed premises. First column is step number. Second column is premises number. Third is premises. Fourth one is we have to apply rule. We have to mention it. Okay. Next, I introduce another premises relevant to R. In these three premises, negation R P is relevant to R. So I introduce negation R P as a second premises. Negation R P. Here, this is our second premises. This is our step 2. Here, we introduce one premises from the given problem. So we have to write rule P. Right? Okay. Now we have one formula P then Q equal to negation P or Q. Right? Negation or P is the form of negation P or Q. So this term can be written as P then Q. So negation or P can be written as R P. Here I use one rule. So I have to write rule P. This is also second premises because this premises get from negation or P. So this is also premise number 2. This is step number 3. Next, compare this premises 1 and this premises 2. R then P. We have formula P then Q is Q. Here we have R then P. So this term can be written as P. Here I use one formula that is rule P. This term can be get from 1 and 2. So I have to mention premises 1 and 2. This is our fourth step. Now I introduce another premises related to P. Here P then Q then S is related to P. So I introduce P then Q then S. P then Q then S. This is our fifth premises. This is first premises, second premises, third premises, fourth premises. This is fifth premises. This is step number 5. Here I introduce premises from given question. So rule P. Okay. Next, consider 1, 2 and 5. Here also P, P then Q formula. See the formula is P, P then Q can be plus Q. Here P, P then Q then S. So step number 6 is from 1, 2 and 5. Premises 1, 2 and 5. P, P then Q then S can be plus Q then S. Here I use formula. So rule P. The formula is P, then Q is Q. I introduce another premise Q. This is our last premise. Now I introduce Q. This is our seventh step. This is premise number 7. Here I introduce premise from given problem. So we have to write rule. Now consider premise number 7 and premise 1 to 5. Q then S formula. We have formula P, P then Q is Q. Here also Q, Q then S. So our final answer is here. I use rule P, P then Q in base Q. I got this from 1, 2, 5 and 7. This number step 8. In this problem, I derive S, answer S from premise R. So we have to write R then S by root C. This is our final answer. I explain clearly. Show that R then S can be derived from the premises P then Q then S, comma, negation R P, and the final premise is Q. In this problem, R then S is the final answer, but there is no R. So I introduce R as an assumed premises. Next, I introduce another premise, negation R P related to R. Here we have formula P then Q equal to negation P R Q. See, negation R P, here negation P R Q. Both are same formula. So this term can be written as R then P. Now we have formula P comma P then Q is Q. Here R comma R then. So this term can be written as P. Next I introduce another premise P then Q then S related to P. See, P comma P then Q. So this term can be written as Q then S. Now we introduce another premise, that is final premise Q. After that Q comma Q then S, that can be written as S. Here root is P comma P then Q is Q. So final answer is S. S is derived from the assumed premises R. By root CP we have write R then S. This is our final answer.